Let's go back and take a look at some data to see if you're understanding the difference between quantitative or qualitative data. So suppose I had a study and my data was the brand names of shoes in a consumer survey. Would the brand names of shoes represent quantitative or qualitative data? Is it numerical in nature? No. So it is qualitative. Heights of students. Are we measuring something? Yes, we are. So it's quantitative. Data. What about the number of robocalls received in one day? Quantitative in nature. Number of calls is quantitative. You can measure it. And then ice cream flavors. Numerical in nature? No, so it is qualitative. The reason we need to know the difference is when your data is qualitative, the suggested charts or graphs, the suggested, probably graph, that you would use to display your data would be a bar chart, which I'm sure you're familiar with, as well as pie charts. So qualitative data will work on bar charts and create pie charts. If the data is quantitative, then we can draw a histogram, a line chart, and if it's over time, we can draw a time series graph. So these are some different graphs that we can create given our data. So the types of graphs you will be creating in your final project, since your data is going to be quantitative, will be a histogram or a line chart. Excuse me. So here are some examples of a bar chart and a pie chart. So we've got a bar chart representing those scores, not scores, excuse me, grades on a test. So we got some grades on a test on our horizontal axis that represents the category or the grades. The vertical axis represents the frequency. So this is an example of a bar chart. Here is an example of a frequency table, and from that table we made the bar. Also from that table we can make the pie chart. Now in the pie chart, each different sector represents a certain percentage. That's why it's important to do the relative frequency column. So each sector represents a certain percentage. And sometimes, when we're doing it by hand, we just kind of have to estimate how big those, estimate the size of those sectors. Okay, when the data is quantitative, that horizontal axis represents numerical values, like when we had the exam scores. So we have our bars here in this histogram. So let me just make a note here. This is a histogram. And this one is a line graph. Notice in the histogram, the bars are touching. There's no space between these bars because the data is continuous. In the bar chart that we see here, the bar graph, I should say, notice there is some space between your bars. That's the usual convention. In a bar graph, you usually have space between your bars because these categories are non-numerical. In a histogram, it looks just like a bar graph, but because the data is numerical and continuous, we usually do not put spaces between our bars. Okay, so this is for quantitative data. And that got a little messy. There we go. Those are the types of graphs we can draw. Notice the line graph. All the line graph does is this. You mark, go with this pink. You mark a dot in the center of each of those bars. You connect the dots and you make it go to the x-axis on both sides. Line graphs are very easy to construct once you have the bar graph. So let's take a look at a table. Got a table that shows ages of all Academy Award winning actresses through 2017. We want to make a histogram and a line chart to display the data. Well, because they asked for histogram and line chart, that's basically telling me my data is quantitative. And if I take a look right here at this first column, this is quantitative data because it's a measurement, it's numerical. And when the data is quantitative, we want to do histograms or line charts. So take a second, work on creating that, and I will do that as well. So pause it, create it, and then we'll compare. So let's look at some particulars on creating, in this case, a histogram and a line chart or a line graph. So we need to have a vertical axis that represents, excuse me, the number of actresses. It represents our frequency. We need a horizontal chart that represents the ages. So this is basically my x-axis, this is my y-axis. You must always label your axes. In this case, the x-axis represents age, so I labeled it as age. The y-axis represents the number of actresses, so I labeled the y-axis the number of actresses. You must label your axes. Okay, then I look to see how high does that frequency y-axis need to go. And the highest value was 34. So I just did these in increments of 5. 5, 10, 15, 20, 25, 30, 35. So I could span all those values. I need to make sure I get all those values on my graph. Then I looked at the x-axis, my categories, and it represented age. So the first one was 20 to 29. So I made my first mark at 20, and then I just went in increments of 10. Because the first one started at 20, the second one at 30, 40, 50, 60. So I just used, basically, these front values. I use those on my x-axis. Then I just created bars. So I make the first bar from 20 to 30 go as high as 32. So I estimated where 32 was. Between 30 and 40, I estimated where 34 was. Went up to 34. 40 and 50 went up to 14. 50 to 60 went up to 2. Then this one, the height was 6. The height was 1, and the height was 1. So I have a bar for each category. So label your axes, pick a scale that works with your particular data. Not only do your axes need to be labeled, you must have a title for your graph. So here we were looking at the ages of Academy Award winning actresses. So that's my title. To wrap this particular problem up, it also wanted us to make a line chart. Well, once you have your bars to create the line chart, you basically just put a dot in the middle of each bar, connect the dots, then make it start and make it stop on the x-axis. So the black graph represents our histogram, the red lines represent our line graph. or a line chart. So they're not too bad to create. One last example in this section gives a time series graph, and it represents the homicide rates in the United States. So let's just take a look at it and summarize what we see. So it starts at 1960, got a starting point, got an ending point of 2012. So again, this is time series. Notice there's a label on the x-axis, a label on the y-axis, and a title. Those are all important factors when you're creating any graphic. What trends do you see? Now, the homicide rates are per 100,000 people. So how do I read that? Let's say right here, it is the number 5. So in 1960, there were 5 homicides per 100,000 people in the United States. In about 1973, looks about right there, there were 10 homicides per every 100,000 people. So if you took 100,000 people and lined them up, there would be 10 homicides. Excuse me. So what do we notice? We've seen some increases. We've seen small decreases, small increases, more decreases. So we've seen the rates sort of have some small dips and turns. Here we see a nice big drop in homicide rates. Then what does it look like happens here? Kind of stays constant. Constant there, 2000 to 2008. But then we see another drop after 2008 here, up to 2012. I would like to get a picture of this or another graphic that goes even further to, let's say, 2019, just to see what happens after 2012, because it sort of looks like it might be swinging back up, but we don't know without having the data. So it's really important to be able to look at a graph and interpret some information from the graph. Like suppose I asked, in this time frame, when was the U.S. homicide rate at its highest? And I'm asking when, so what year was that? Well, I'd come over here, look at the highest peak, and the year for that looks like maybe around 1980. We saw the highest peak in homicide rates. Where did we see the lowest homicide rates? Well, I could look at this guy here. He's pretty low. And actually, he looks lower than this guy. So I would say maybe 2012. It might be a runoff between 2012 and 1962. But there we see some low homicide rates. Work on the homework in my math lab. Let me know if you have any questions, and we will end this video right here.